When the refrigerant flows from the compressor to the right side through the four-way valve, the right heat exchanger works as a condenser. Then the condensed refrigerant expands through the expansion valve on the left heat exchanger side, and the left heat exchanger works as the evaporator. The evaporate refrigerant returns to the compressor and the cycle is completed. Next, when the refrigerant flows from the compressor to the left side through the four-way valve, the left heat exchanger works as a condenser. Then the refrigerant flow in the opposite direction expands through the expansion valve on the right side and evaporates in the right heat exchanger. In this case, the right heat exchanger works as the evaporator. Temperature sensors and pressure sensors are installed at the compressor inlet and outlet, expansion valve inlet and outlet, left heat exchanger inlet and outlet, and right heat exchanger inlet and outlet. These sensors are connected to KTE's DA100 software, so you can check temperature values, pressure values, calculated values, and the pH diagram in real time. A low pressure gauge and high pressure gauge are also installed separately. The control section includes a power module, switch module, and lamp module, push button switch, relay, and magnetic contactor. The main loads are the compressor motor, four-way valve, solenoid valve, heat exchanger 1, and heat exchanger 2. Also, the fan motor speed of heat exchanger 1 and heat exchanger 2 can be controlled. There is also a display that shows the voltage and current of the compressor in real time. The basic temperature display setting includes compressor in, compressor out, heat exchanger 2 out, heat exchanger 2 in, expansion valve in, heat exchanger 1 in, heat exchanger 2 temperature, heat exchanger 1 temperature, heat exchanger 1 out, and ambient temperature. The temperature of heat exchanger 1 and the outlet temperature of heat exchanger 1 can be used for feedback control. Finally, the signal port is installed so that KTE's PLC training set can be connected. This allows students to practice PLC control training as well. Now we will show a demonstration of switching between heating and cooling operation. First, for safety, we connect the main power and relay through the stop push button and start push button. Then we check if the relay operates properly. Next, we make a relay self-holding circuit. We check if the self-holding circuit operates normally. Next, we use another relay A contact to operate the compressor motor and the fan motors of heat exchanger 1 and heat exchanger 2. After that, we connect the 4-way valve to the main power through the toggle switch. When the toggle switch is turned on, the system operates in cooling mode based on the left heat exchanger. The left heat exchanger, which is heat exchanger 1, works as the evaporator, and the right heat exchanger, which is heat exchanger 2, works as the condenser. From the PCB board shown on the left side, up to 18 temperature sensors and 18 pressure sensors can be added for data communication. The received data is sent to the software, so you can check the pH diagram and result values in real time. Also, all data can be saved to Excel at intervals as short as 1 second. You can check the temperature values and the voltage values and current values of the compressor. By turning off the full-way valve, heat exchanger 1 can be changed to heating operation. In this way, you can test the system by turning the 4-way valve on and off to change the low of the heat exchanger. Thank you for watching the introduction of our low-cost heat pump system.